Welcome back, reinforcement learning. This session I explain the curiosity driven exploration. Curiosity driven exploration, it is a human based learning approach in reinforcement learning. The curiosity driven exploration is an approach in reinforcement learning that addresses the sparse reward problem. The sparse rewards problem is infrequent rewards. Okay, they are unexpected rewards, they are not frequent rewards. Infrequent rewards problem we are addressed by using curiosity learning approach. The traditional reinforcement learning algorithms like deep Q neural networks and policy gradient approaches cannot get the optimal rewards in infrequent reward environments. So the Atari game Montezuma revenge game, the rewards are sparse and compared to games with frequent rewards like a breakout. Okay, these Q-learning and policy gradient approaches, they are not given best results like frequent rewards like a breakout. So we need some another approach to solve the sparse rewards problem. So the researchers, the scientists turned into the find out the curiosity driven exploration. This is introduced intrinsic motivation inspired by the human and animal behavior with curiosity to encourage reinforcement agents to explore and learn even in the absence of frequent external rewards. The curiosity driven approach we are using to solve the sparse reward problem. The sparse reward problem occurs when our rewards are infrequent, distributed within environment. The rewards are distributed infrequently, making it difficult for agent to learn effective strategies through trial and error. The results are distributed infrequently. The agent cannot trained properly to get the optimal rewards. So in the games Montezuma Revenge, the rewards are only given after completing specific tasks. So when the tasks are completed, all tasks are not in same distribution. So they are different distributions. So which can lead to lack of learning if the agent does not encounter these rewards frequently enough. So this is the problem. This issue is illustrated in the document where it is noticed random exploration may not yield sufficient reward signals for the agent to reinforce its actions learn effectively. So the sparse rewards problem, the environments where rewards are distributed infrequently, making it hard for agents to learn optimal policies. So example, the Montezuma Revenge agents must complete challenging sub-goals like finding a key before receiving a reward. So the sparse rewards problem is the rewards are distributed infrequently. Now we need to solve this problem by using curiosity as an intrinsic reward. So to combat the sparse reward problem, the researchers have turned to principle of human intelligence, particularly the innate curiosity and drives the exploration. Innate curiosity and drives the exploration. This curiosity can serve as an intrinsic reward, motivating agents to explore their environment and develop the skills necessary to achieve sub-goals and ultimately find the sparse rewards. The curiosityness of the humans or animals, this approach we are embedded in reinforcement learning to solve the sparse reward environment games. This approach allows agents to learn and adapt even in the absence of frequent external rewards. The curiosity, intrinsic motivation, the inspired by the human curiosity, agents are driven to explore and understand their environment. The curiosity serves as an intrinsic reward mechanism, enabling agents to learn useful behaviors even without extrinsic rewards. With curiosity, we do some work. So this is the intrinsic motivation. So predictive coding model, this is the basic model for the curiosity driven reinforcement learning approach, predictive coding model. The predictive coding model we are taking from neuroscience, the neuroscience which posits that neural systems continuously attempt to predict sensory inputs and minimize prediction errors. The neural system continuously attempt to predict the sensory inputs and minimize the prediction errors. This model suggests that when agents encounter unexpected events, they experience a prediction error that prompts them to update their understanding of the environment. By incorporating this model into reinforcement learning, agents can enhance their exploration strategies and improve learning outcomes. So, the predictive coding model is the neuroscience inspired model where the brain minimizes the error between predictive and actual sensory inputs. The RL agents can similarly use the prediction errors to evaluate and adjust their exploration strategies. So, we are using predictive coding model in reinforcement learning to solve the infrequent rewards. The implementation part, we are using practical examples for implementing the curiosity driven exploration in reinforcement learning agents, such as the training an agent to play Super Mario Bros game using the curiosity alone. This demonstrates how agents can navigate dynamic terrains and achieve goals without relying solely on the external rewards. They are using here the curiosity alone approaches. In this implementation, we are using intrinsic curiosity module and training without extrinsic reward. These two are the important parts in curiosity implementation models. So, the intrinsic curiosity module, an architecture that computes the intrinsic reward based on prediction error. And example, implementing the ICM in PyTorch to enhance the exploration of the rewards. The training without extrinsic rewards. The using curiosity driven exploration, agents can train effectively in environments without external rewards. Okay, these two are the important parts in implementation of the curiosity modules. The curiosity driven exploration address the space rewards problem in reinforcement learning by leveraging the intrinsic motivation. The agents can learn effectively by exploring their rewards and developing the skills to achieve sub-goals. And the predictive coding model provides the framework for the understanding how agents can minimize the prediction errors and enhance their learning process. The practical implementation, such as the training agents in games, and show the potentiality of the curiosity models to solve the complex environments with infrequent rewards. Okay, these applications of the curiosity driven exploration, the game environments with infrequent rewards, we are using the curiosity driven model. And problem solving, we are solve the task requiring the long term planning where the immediate rewards are not available. In that case also we are using curiosity driven exploration. The game environment train the oral agent to play the games like Super Mario Bros. Using the curiosity alone, agents learn to navigate the complex environments with infrequent rewards, focusing on reducing the uncertainty about the environment. These are the applications we are using with curiosity driven exploration in reinforcement learning. Curiosity driven exploration expands the reinforcement learning capabilities for the agents by incorporating the intrinsic motivation. This approach allows the agent to overcome the limitations of this space reward settings and achieve the task requiring the complex exploration and long term planning. Thank you.